Hello and welcome back to the lab. Today on the bench is a pile of parts. I have been told this pile of parts is a TM5000. Is it an A? No, it's just a TM5006. This is not a functioning unit at the moment. It needs some help and some service, so we're going to see what we can do there. One of the interesting things and what led me to pick this unit up is it actually had the rack mount rails to it. According to the manual, if you have the perforated side panels on this particular model, you don't need any bottom clearance. So I can stack this right on top of another module, and this grating and the perforated side panels are enough to pull air in through the unit. So I also want to do some modifications to this, so since I got to go into it and fix it anyway, it's a good chance to actually get some things modified. I've already started a little bit on this, and I was talking to a few people, and they thought it would be an interesting video, so here it is. So for right now, where I'm at is, I know the fan is bad. I tried fixing the fan, and I pulled off the wrong part. So this is just a 110 volt AC fan, but I pulled off the wrong part, and now the fan won't spin at all. So I have accidentally killed this one, which is fine. There was a spring-loaded compression spring that I thought had to come off to get the fan apart. That does not, but I do need the tails that comes off of it, because I need these plugs, and I need this connector. So we'll be making another fan. I have figured out a replacement, so I'll be detailing some of the replacement parts that I'm using, just in case anybody has similar issues on one of these power frames, because I did have to source some parts. Overall, cosmetically, the unit is in very nice condition. I haven't cleaned this or anything like that yet, but it is incredibly clean on the inside. Something to know about all the TM series frames is these are the pass elements. I did a video on rebuilding one of these, and I'll probably do the same thing. All these caps will get replaced. These caps down here will get replaced. Move this out of the way. This is one of the modifications that I was starting to do. This is a BNC on the back panel. My goal is to have a TG501, and I'm looking at hooking it up to the Rubidium. So we'll be doing that conversion in this video. Might make a second video on that conversion, but it will also be a part of this video as well. These pass elements interact with different plugins in different ways. You want to be very careful if you pick up one of these frames, because I know people that have popped a plug-in in. One of these pass elements is bad, and it blows the plug in. There's a PNP and an NPN for each slot. There's two down here. So 1, 2, 3, 4, 5. And then there's some high current ones down there for the high power slot. So those are our pass elements. One of the quick ways I test these power supplies when I bring them in, since I've had to test a few of them, is I have just a generic power supply that I plug in and just sanity check, because I know this uses the pass elements. So I just sanity check all the slots just to make sure everything fires up and it doesn't damage that power supply. If it doesn't damage the power supply, it's probably safe to plug something else in. But since I have it out and I have it open, I will be testing all of these just to sanity check them and make sure their HFE is okay. The other thing to note is, given your serial number and time frame of construction, the pinouts on these pass elements can be all over the map. So be very careful with the pinouts if you ever have to replace one of these. Know what the pinouts are and get the same pinouts, or you have to rewire this connector so it doesn't pop the plug-in or the new pass element. These, on the previous video that I did, were NTE parts, and they were not cheap. I think they were like $30 a piece. So I bought a couple of them, and got one that fit. That's really about it. I'm going to take the, well, since the fan's off, we can just take the bottom panel off. Just slides out. So let's see. Here's the, take this panel off to get at the board, but then I'll have enough room to work to replace the capacitors in there. So let me get this off real quick, and then I will be right back. All right, it's a little late to start up the compressor today to work on those capacitors, so we're going to start with testing the pass elements. So here's the first one. That one's good. And good. And good. And good. And that one's good. 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 Really low HFE on that one though, but it is in the same range as the other ones. Good. Good. And last one is also good. So all our pass elements are good. I can't really check the high current ones with this test fixture because it's hard to get the leads on them. So I will test that with the power supply, and that'll be good. So the next thing I need to address on this particular unit is the fan, which was horrendous when I fired this one up. But you'll notice underneath this heatsink, there's a transformer hiding under here for a switching power supply. So on the 5000 units, they are switching power supplies. On the 500 units, they're linear power supplies. That's one of the main differences between the two. Although this does have some pretty massive transformers in it, so, but they got transformers all over this thing. There's one here, there's 3 down there, or there's 3 over here in a row. There's this massive transformer right here. So they're all over in here. Okay, to address the fan, I was able to pull the part number off of this fan. It is actually a muffin fan. And I found out, I believe if I remember the data sheet correctly, this is a 102 CFM fan. So I was able to find a 110 CFM fan that was actually quieter. There is the part number. And there's our fan. Ball bearing fan instead of sleeve, 17 to 15 watt. Oh, 15 watt on 60 hertz. And it's a 120 volt AC fan, which is what we were looking for. And that's actually going to move quite a bit of air. So we need to get that in there. But before we do that, I need some leads. Okay, just testing the new fan before I put it in. This is extremely dangerous. This is mains voltage right here. No, my finger is about 2 feet away from the plug. There's no depth perception in the camera. That's why it looks that way. So I'm nowhere near the bench right now, and I'm powering this off the isolation transformer just to test the fan, see how loud it was, and also check that it's spinning the right direction. Yes, AC fans will only spin one direction. Not like DC where you can reverse the polarity and they'll spin a different direction. But I have had a fan not put together right before, and the markings were bad. But this one's right. So now what I have to do is I have to get that in there. Now the fun part, playing with fire. Well, that was fun to put back together. The one of the pins got a little bit damaged, so I had to open it back up with a meter probe. My probe master, the very tip of the probe, pushing it into the pin, opened it back up and allowed it to get down on the pin on the board. But I will show you where this plugs in. Right, way down there is where the fan actually plugs in. So It's kind of fun to get that down in there. Let me grab a power cord here. Okay, we're looking for fan spin. There we go. That is moving a substantial amount of air. It's not hitting anything either, so that's good. And we are off to the races. We're drawing about 40 watts out of the power supply, so it's all fired up. Turn that off for now and continue on with some repairs. It's gotten a little late to fire up the compressor tonight for the N2 iron, so I'm going to save that for tomorrow. But the next thing on the list of stuff to do is going to be to replace these two caps and then the capacitors over here, which are the bulk filters, as well as some stuff down on the other side. The nice thing about this is, now that we have the DC load, we will be able to check the power rails at their rated loading them, so we'll get a really good sense as to if the how the power supply is doing after we get new caps put in. Okay, time to tackle the capacitors in the power frame. The ones I got to do first are hiding well under here. It is possible to get a soldering iron under here and get at these capacitors and remove them. It's kind of a pain in the butt for the desoldering tool because of the lip right here. So what I'm going to end up doing is I'm going to come in with 2 soldering irons and do each cap at a time and pull them out. So I'm going to work on those. The first set is... focus. There we go. It's these blue ones here that we're going to replace. So let me pop those out, and then we'll go from there. Okay, with a fresh batch of electrolytic capacitors in there, I'm going to have to do the adjustments on the frame, but for now I'm just going to let it burn in for a while, no plug-ins, and we'll go from there. So I'm going to start this up. Actually, pop this back in. I'm going to start this up, and we'll do that on camera. If I got everything in the right polarity, we shouldn't see any smoke. No poof. Okay, right now, according to my power meter, my line voltage is running about 120 volts right now. So here we go. And we're drawing about 45 watts on the frame, and we're down to 39 already. So that's good so far. This is nowhere near the electrified parts, so we can move it safely. Gonna check my voltages, make sure everything's healthy, because the last time I did one of these, one of my rails was dead, but so we'll just give it a quick check. And we have 8 volts, negative 25, positive 25. Okay, all our rails are there and healthy. So we will just sit and let that cook, make sure nothing pops off for a while, nothing overheats, and everything's fine, and then we'll put some load on it. Okay, I'm testing the 18-volt rail, or the 8-volt rail, sorry, and my maximum power delivery on the 8-volt rail is going to be 18 amps, and it needs to supply 8 volts. We're at 8 volts on the connector. Now, there's a lot of current going through the cables, since those cables are actually only rated for about 10 amps. So I'm pushing the leads very hard. So I don't want to do that for very long, but I'll show you the load. So with the load on, we're dropping a volt in the wires. So that's why I'm checking it with the meter. But the 8 volt is good. All right, here's the test setup for the plus 26 volt rail. We're running at 25.1, which is fine. And I will turn the load on now. That's full 6 amps on the load. And that rail is fine. I'm going to have to reverse the polarity for the negative because I have to keep the voltage positive with respect to the load. So I have to reverse the leads. So I'm going to do the negative supply, but it will look positive based on my testing only because I reversed the leads. The leads are reversed for the negative rail. So we have a positive voltage again. Put the load on it. And we're at 23.7, so that looks fine too. It should also be noted that I'm drawing a full 6 amps out of this rail. And there's the load. Okay, well, since this one doesn't have any feet, and I was thinking about putting some feet on it, I ran this off on the 3D printer. Now, this geometry is not the simplest thing in the world to draw up in, come on, focus, in a CAD tool. This channel needs to slip in like so, and that one does. Well, that's fantastic. It's a little stiff, but it's not bad for a first run. So there's another feature I'd like to add to this that has, there's a notch that needs to bump up to cover the space so it rests on the case at the bottom. So let me make some more edits. We'll do up a second prototype, and then if that works, I'm going to make some long ones. My plan is to make some long ones that'll cover this entire channel. Now, that's going to max out my 3D printer, so I may have to do it in two pieces, but we will go from there. So here's the second prototype that I came up with. We have you can see the difference. So they're still flat on the bottom, which is fine. I also made them a little taller than the original foot that goes in the power frames to give it some more airflow and some cooling to get it off the ground a touch more. So let's get a lid and we'll see if that one fits. All right, so we got front top cover back on. Here's our Gen 2. Okay, our Gen 2 does fit, but if it gets, the tolerances are very tight, so if it gets cocked a little bit, it doesn't want to move. But it is working, it is sitting, so I'll get the long print done and we'll get the large feet made. They're going to go on the bottom. And we'll just slide the trim back in this rail. Okay, while I've been waiting for the print to finish up, I did the modifications on my TG501 to set it up for an external 5 megahertz reference clock. So I don't know if I'm going to have to build an amplifier for it or not to see about getting it working, because the Rubidium unit in the lab puts out plus 7 dB into 50 ohms, which is about 2.2 volts unterminated. So I don't know if it's going to be enough to get the clock chip excited. If switching happens, it'll work. But if I need to put an amplifier into the port, we'll see how it goes. So this is going to go in the front just like normal. And I'll flip this around. So here in the back we have this port here that I'm going to label for 5 megahertz because that's what I have the unit set at if everything is working the way I expect it to. And we'll see what happens. Let's get it all hooked up and we'll go from there. All right. 200 millivolts should be fine. We'll DC couple this. That should be all right. Left. That'll work. All right, we'll turn the frame on. And we shouldn't get anything due to having no clock. Having fixed one of these before, we can see it's got power, which is good, but we don't have any clock signal. So if everything works, when I apply this clock signal, we should get time marks. Oh, there it is. It's triggering. Hey, look, there they are. Now, this isn't going to be totally stable until... Let me zoom in on the scope. And there we go. So we're getting time marks out of the TG501. So that means we are actually on Rubidium-stabilized time mark generator for the lab. So that is fantastic. I'm just ecstatic about that. So that it was enough for the chip to figure itself out. So I got to get a label made up for that, wait for this 3D print to finish, and then we ought to be finished up with this power frame. One thing to note, if anybody's curious about how to modify a TG501 to use an external clock and a more stable reference, I did a video on that previous in the channel. It's in the extensive repair of the TG501 that I fixed previously. So that one ended up needing an external clock because the oscillator was toast. Well, the 3D printer got done, and it is the tallest thing that I've ever printed. These are full-length feet. They're 220 millimeters each, so it'll be a total of 400 millimeters on the side. In very close inspection of the 3D print, it looks like, yeah, right here, it looks like a single step got lost. You can see the difference right there where my thumb is. You can see the difference in the print. So we'll see if these go on. I'm going to get this flipped over and get these put on, and then I'll show you guys what it looks like. Well, my dimensions were a bit tight, so I either saved it or I killed it getting these things on there. We will find out here in a moment. Well, we have power and we have time marks, so all is good there. So what I need to do now is I need to get the rest of the side panels on, put the back ends that I have back on, because I don't have the bottom ones. That's why I made the dimensions kind of tight so they wouldn't slide around. And then this frame will be able to be put into service. And we have one more power frame ready to work hard in the lab. I'm going to let this test for a while, just sit here and burn in, and we'll go from there. I threw a bunch of meters in there just to do a noise check of when the fan was running, because these tend to be more noisy when they're empty. It is kind of noisy. Like, it's not quiet, but that fan's moving a ton of air in the back. So I'd say it's a little louder than my other two, but will I be bothered by it? The scope calibration stuff is going to go in here. So this particular frame will only be on when I'm working on calibrating a scope. So this isn't going to be an everyday driver frame. So the noise is not too much of an issue. For the meters and stuff that are everyday drivers, they're in passive frames, passively cooled, and they're dead silent because there's no fan. But especially with the PG506 and a few of the other ones, they tend to run really hot. So having them in a force-cooled frame is a good idea. So thanks for stopping by the lab, and I will see everyone in the next video.